All right, we're going to do 4 polar coordinate questions. Tricky stuff. Like many of the AP problems that I discuss, I want you to keep in mind that you don't have to get every aspect of it right. Okay, so just keep that in mind. Let S be the region bounded by the graph of the polar curve, 3 root theta sine theta squared. Notice it's a calculator problem. Wants me to find the area of S. Okay, I'm going to do the work up here just for space. So for part A, this says from 0 to root pi. Let's see what happens if I put sine of pi in. That's 0. This all zeros out. Put in 0, it all zeros out. Okay, it looks like it's working. So the area is 1/2 integral 0 to root pi. And let's be lazy. R of theta squared d theta. Okay, put that in our calculator. I've got a sneaking suspicion we're going to need this at some point in time. So I am going to put in that formula in here. 3 root theta. By the way, I don't know if I need to be in polar. I think it would work if I'm not in polar. Sine, I do need to be in radians though. Theta squared. Math. 9. Forgot my 1/2. 0 to square root pi. Parentheses alpha up here. Let's me pick R1. Parentheses squared with respect to theta times 0.5. 3.534 equals 3.534. No units. Done. That's it. All right. Put a little S up here. I could write the area of S if that helps you. Doesn't matter. Cool. 2 points. Bonus. What's the average distance from the origin to a point on the polar curve? So this freaks people out. And if you can't get it, that's fine. Remember that R is just simply the distance. So average distance is, we've done this before. I'll throw it up here. The integral across the whole area, 0 to root pi, over that gap, 1 over root pi minus 0. And again, if you're like, wow, how would you ever know this? I could not imagine doing this. Don't worry about it. This is the first time we're doing it. It'll come. So that'll give the average R. It'll be like, I don't know. I'd have to figure out how far away that is and then say it's like 0.5 or something like that. Not that it matters. I just like to have some idea what I'm dealing with. And I think we get 1.580 rounded wrong. That's the average distance. Another 2 points. Woohoo! On a roll. Okay. So there's a line through the origin with positive slope m that divides the region S into 2 regions with equal areas, right? But do not solve an equation involving one or more integrals whose solution gives this value of m. Right, the areas are even. Oh, sorry, I don't think that's all that hard. Well, hang on, let me slow down, make sure I get this right. There's a line through the origin with positive slope m. Oh, that's not a location, is it? So positive slope m. Well, that's hard. I think I could do this without the limits and get close, but we'll see. So some line here, y over x equals m. I need theta. Why did I write this up here? That's very weird. Y over x equals m. I need theta. Tangent of theta I know equals y over x. Oh, so theta is just the arctangent of y over x, which is m. So tangent to the negative first of m. Okay, that's pretty easy. 1/2, which I don't need, but I'm going to put it in there. I'll explain why I don't need it in a minute. 0 to theta, arctangent, -1st of m. By the way, I certainly couldn't have done this. And that's not just saying it. I mean, I literally could not have done this the first time I tried it. R of theta squared d theta equals 1/2. And that's what I mean. I could probably cancel both 1/2s, but why not be thorough? Tangent to the -1st of m to root pi, r of theta squared d theta. Getting messy, but yeah, that'll do. So yeah, that's it. Yeah, I've seen it done a couple different ways. That's 3 points. This is the hard part here, is understanding what that was. And quite frankly, I had no idea how to do this. I looked at the answers and I saw some tangent. I said, wait a minute, that's right. M is y over x. And yeah, that works. That's a little experience there. Okay, let's look at the bottom one. For k is greater than 0, let a of k be the area of the portion of region S that is also inside the circle k cosine of theta. Cosine is going to be over here. Kind of nice to know that. Find the limit as k approaches infinity of a of k. So this will get bigger, bigger, bigger. So what that means, if I'm looking at this right, is that eventually the circle will get so close to here. It's basically the area of S inside here. So I'm going to go out on a limb and say the limit as k approaches infinity of a of k is going to be 1/2 integral from 0 to pi over 2. How do I possibly know it's pi over 2? That's 0, pi over 2 of r theta squared d theta. Wow, that's a tough problem. Which, if I blast it out on the calculator, is 3.324. Get my squared in there. Making sure I'm doing this right. Don't want to give people wrong information. Yeah, that's right. 3.324. I've seen that before, so I remembered that way, way, way deep in my memory bank, but that one's tough. I warned you. Not easy. All right, back to 2018. Graphs of the polar curves r equals 4. That's the circle here. And r equals 2, and the curves intersect. Hey, check it out. That was nice of them to say that. Pi over 3, 5 pi over 3. Let R be the shaded region inside the graph. Notice we don't have a calculator. It's probably going to be right. Don't. Yep, there it is. Right. Don't solve. Also outside the graph, r equals 3 plus 2 cosine theta. All right. So the circle's farther out than the inside. So unless I am mistaken, we're looking at ½ pi over 3 to 5 pi over 3. Outer one, 4. Did they give them names? They didn't. I got to write it all out. 4 squared minus 3 plus 2 cosine of theta squared. D theta. That's it. That's 3 points. I find that shocking. Yeah, they're just seeing if you know how to do it. Okay, whatever. See what's going on with the next piece. Find the slope of the line tangent to the graph of r equals 3 plus at theta equals pi over 2. Okay, got a little work to do. X equals r, 3 plus 2 cosine of theta. Yeah. 3 plus 2 cosine of theta. X equals r cosine of theta. Dx d theta equals, leave it, derivative, right? Leave that part, derivative, we get -2 cosine of theta, cosine of theta. And we're doing this at, they're going to give us something nice to work with, pi over 2. Pi over 2. So I'm actually going to keep going in terms of what do I get with that? Equals Cosine of pi over 2 is 0 by 3 negative sine of pi over 2, negative 1, 3 times negative 1 plus 0. Negative 3, I hope that's right. Yeah, it looks okay. I'm going to keep going up here. B continued. Y equals 3 plus 2 cosine of theta, sine of theta, dy d theta equals, leave it, cosine of theta plus derivative is wrong. This is right. This is wrong. Leave it, derivative, vanish, cosine negative 2 sine. Naughty, naughty, naughty. And derivative negative 2 sine of theta, and leave it sine of theta. Okay, at pi over 2, let's do this one first. 0 by dy d theta, theta equals pi over 2. Naughty boy. Equals cosine of pi over 2 is 0 plus negative 2, whoa, sine of pi over 2 is 1. Negative 2 times 1, negative 2 equals negative 2. dy dx equals negative 2 over negative 3 equals 2/3. Really hard? I don't like that at all. I prefer not to do that ever again. Let's see, that's 3 points. Wow. So, yeah, that's correct. Cool. All right. Last but not least, particle moves along the portion of the curve. Particle moves in such a way that distance between the particle and the origin increases at a rate of a related rate, 3 units per second. Find the rate at which the angle theta changes with respect to time. It is when the piston. This seems very weird. I just did one of these recently, and I know they want this nonsense. I want d theta dt. Let's see, and so I have to say that equals d theta dr. Yeah, I got that backwards. Dr d theta. Well, what do they give me here? Well, it says the distance between the particle and the origin. That's r. Increase at a constant rate of 3 units per second. So I'm going to write over here, dr dt equals 3 units per second. I'm not going to put in those units. So I want d theta dt. I got a dr dt. I need d theta dr. Dr dt. Cancel. There we go. Something seems weird about d theta dr, though. Oh, because I'm a moron. This is not what I want at all. I want dr dt. And the rate at which the angle theta changes for time with the instant. I have dr dt. This didn't add up. I knew something was wrong there. And I can do dr d theta times d theta dt. Have it, can find it, that'll get whatever's left over. So this means that 3 equals dr d theta. Dr d theta, I'm going to throw it out here. Dr d theta equals derivative by negative 2 sine of theta. Negative 2 sine of theta. They want to know when theta equals 3 times d theta dt. 3 equals negative 2 sine of pi over 3 d theta dt. D theta dt equals 3 over negative 2 times sine of pi over 3 is root 3 over 2. Cancel. Equals negative 3 over root 3. That's an answer. Equals negative root 3. That's also an answer. Root 3 over root 3. Cancel. Yeah. I nearly forgot. This is d theta dt, so that would be radians. units per second. Wow, I did it right. Well, I'm shocked. Yeah, this one caught me off guard. Remember, you only can do dr d theta. We could have solved it for theta and solved the other way. That would have been a bad idea. So start with that, start with this, and then relate the three. Seems to be the best way to do it. I'll roll. By the way, if you're thinking these are hard, that's why we're doing them. Okay, figure above shows a polar coordinate curve f theta, 1 plus sine of cosine 2 theta, and 2 cosine of theta. This one's easier. Let's put in 0, 2. Okay, so this is g of theta. Just to help me keep it straight, g of theta, and this is f of theta. Plug in 0, cosine, sine of 0, go 1. Yeah, that works. Okay. Let R be the region in the first quadrant, bounded by the curve. Let S be the region, bounded by the curve. Okay, so R is this area. And S is only this area, just to make sure I'm reading the full question correctly. The area of R. Go up here and do it. Area equals 1/2 integral. They don't tell me. Oh, yes, they do. Pi over 2. Let's make sure. I should get 0 when I put in pi over 2. Cosine of pi is 1. Sine of pi over 2, 1. That doesn't add up. Cosine of pi is -1 plus 1. Yeah, that works. 1/2, 0 to pi over 2. Calculator time. Let's be lazy. F of theta d theta equals, blast it out in the calculator, 0.648. The ray theta equals k. Theta equals k looks like this. Where 0 looking, right, divides S, just talking about S here, into regions of equal area. Right, but do not solve the equation involving one or more integrals and solution given the value of k. So that's theta, that's fine. So B means 1/2 integral from 0 to k. Now, S is actually the outer minus the inner. So boy, it's a good thing we can write it this way. G theta squared minus F of theta squared d theta equals, I don't think I can fit it here, 1/2 integral k to pi over 2 g of, I think I got too many parentheses here. Might as well. G of theta squared minus F of theta squared d theta. I'm not mistaken, that's it. Yep, I could actually get rid of the halves, like I said, but I'm going to leave them because there's nothing wrong with them. It's correct. So, hey, 4 points. All right. I have a feeling that something evil is about to happen here. C, for each theta, 0, let W theta be the distance between the points. So this is very common. We have to remember that's going to be R2 minus R1, where R is really, it's right there. R is that. Really going to be the further one, G of theta minus F of theta. Okay, let's read the question. W theta be the distance between the points of the polar coordinates and whatever. Write an expression for W theta and then find the average value of W theta from 0 to pi over 2. We'll come down here and do it. W theta, excuse me, equals G of theta minus F of theta. Done. If you really feel the need to go right into your equations, go ahead. That's it. That's good. That's done. W A, find the value of theta for which, hold it. Find WA, the average value of the interval. Should not have done that. The average value, it's going to be the interval 1 over pi over 2 minus 0. Integral 0 to pi over 2, W theta. That's it. I would probably have plugged these into R1 and R2 in my calculator. Just blast this out. It's hideous. It's 2 over pi. If you want to do that, you should get 0.485. All right, 1 to go. Using the information, find the value of theta for which W of theta equals WA. D. And everybody was asking me, what if I screw up C? Do I get to use this value? Yes. And us poor graders will take forever to fix it. W theta equals WA. So 0.485, that's WA, equals W of theta. W of theta is G of theta minus F of theta. Let me get this to focus a little better. I think if I come down, it'll help. Yeah, not the greatest. Okay, I'm gonna have to take a derivative of this later. We'll talk about that then. Let's see, find the value for which W theta equals WA. I'd have to put this into the calculator, put Y equals, so yeah, I would do this in Y. Y equals 0.485, and then I do Y equals this whole nasty mess. Then I would use the intersect button and find out that theta equals 0.518. Now we have to find the derivative, and I would use a calculator to do this. W prime of theta, goodness gracious, W prime of 0.518. Put that in the calculator, get a number, is negative. So what's the question? Increasing or decreasing? W of theta is decreasing. If you got A, B, and C, great. If you got A and B and part of C, great. If you got all 4, amazing. But if you get 6 or 7 points on a nasty question like this, take it and run. All right, onwards. 1 to go. Did we really already do 3 of these? Feels like pulling teeth. Yep. All right, back a little ways to 2014. Graph the polar curves R equals 3. That's this one. I'm not even going to label it. It's a circle. And R equals 3 minus, yeah, okay. Funky stuff. Shown, let R be the shaded region inside the graph of R equals 3 and inside the graph of, yeah. All right, so let's do this in 2 pieces. Let me read the question. Find the area of R. So I'm going to go with 1/2. Area equals 1/2 integral 0 to pi over 2, because that's the 90 degrees. That's where they intersect. Are you sure they intersect there? Plug in pi over 2. 2 times pi over 2 is pi. Sine of pi is 0. 3 equals 3. Thumbs up. And R equals 3. Oh, I can't cheat. It's no fun. 3 minus 2 sine of 2 theta squared d theta plus, I can do an integral, but I mean, it's just pi 3 squared over 4. Calculator problem, so we need an answer. Blast it out. 9.708. Cool. That's worth 3 points. Seems kind of easy to me, but what do I know? For the curve R equals 3, find the value of dr d theta at, all right. I gotta do dx d theta. Can I read or no? Yeah, I think I can read. X equals R, 3 minus 2 sine of 2 theta, cosine of theta, dx d theta equals, leave it, negative sine of theta plus derivative sign is cosine, 2 out front, negative 4 cosine of 2 theta, cosine of theta. Notice how easy it is to make mistakes there. You got to really be careful. At pi over 6, okay, sine of pi over 6, sine of pi over 3. Darn, I thought they'd give me an easy one here. 3 minus sine of pi over 3 is root 3 over 2, root 3. Negative sine of pi over 6, negative 1/2, plus cosine of pi over 3, 1/2, negative 2, cosine of pi over 6, root 3 over 2. All right, it's calculator. I probably should have just done all this in a calculator. Blast it all out, you should get negative 2.366. And this is actually a great example. If I should have known it was calculator, I could have done this in the calculator easily. X equals pi over 6. I probably should have written it here. Dx d theta, x equals pi over 6, and not written it there. Not that it really matters. Cool. All right, let's go down to the bottom here. Distance between two curves changes 0 to pi over 2. Find the rate at which the distance between the two curves is changing. Hey, this sounds familiar with respect to theta when theta equals pi over 3. So let's see, distance equals 3 minus 2 sine of 2 theta equals 2 sine of 2 theta. Weird. Find the rate at which dr d theta equals pi over 3. Just do it in a calculator. I mean, I'll do it here. Is 4 cosine of 2 times pi over 3, which is cosine of 2 pi over 3 is negative 1/2. It's negative 2, which is what you should get in a calculator. That's it. Done. 2 points. Nice. All right. D. Particles moving along the curve, related rates problem. So d theta dt, d theta dt equals 3 for all times. Find the value of dr dt at theta equals pi over 6. Back to the mistake I made before. I know that dr d theta equals dr d theta dt. Let's just write that in, see what happens. I'm lost. D theta dt times dtd. That doesn't work. Cross. Dr dt. Aha! Gotcha. Equals dr d theta times d theta dt. Cross, cross. Looks good. Give me this. That's 3. They want what? They want dr dt. All right. So dr d theta. Didn't I already do this? I did. Wow. Okay. Well, it's a calculator problem, so keep life simple. Dr dt equals dr d theta at theta equals pi over 6. We did pi over 3, so they're cheating a little bit. Times negative 2. Let's see, at pi over 6, it's like pi over 3. Cosine of pi over 3, 1/2. You get 2. Why did I write negative 2 here? Because I saw it up there. It's right there, you dummy. 3. What did I just say? Negative 2 times 3. Why did I get negative? Pi over 6, pi over 3. Oh. Well, now I'm confused. What else is there? dr d theta. There's a negative out front. Oh, here it was 3 minus. Naughty, naughty. This is not dr. This is d distance. So yeah, this would be different. Equals negative 6. Wow, that'll keep you busy, huh? Good luck.